Hi, my name is Cyrus and I'm going to present on the design. So the selected design includes four wings for the payload as shown in the diagram. It consists of four wings that are attached opposite to each other. The wings are placed at 90-degree angles from each other so that it can be adjusted in every direction possible. All the wings are in opposite direction to each other. The wings will be attached to a ring with the help of a fastener, and the ring will be then attached to the payload. This will create a drag whenever necessary with the help of the actuators. So moving on to the wings design. The wing design consists of 13 actuators that are placed on the wing in a format that the actuator will be able to work from both the sides. The wing also consists of vanes for smoother dynamics on the end and front of the wings. All the wings will be internally connected through a control chip for smoother working of the actuator, which can help to reduce the drag force very efficiently. So moving on to the next part, that is the working of the design. This design consists for the payload is made in such a way that it can easily reduce the drag force. The four wings will help to reduce the drag from all the four sides, which means if the drag force is exerted from one opposite direction, it can also be controlled from the other direction, and the payload can be adjusted with the help of the four wings and actuator. The four wings will help to reduce the drag force from all the four sides. The wings are provided with actuators which will activate according to the requirement in the opposite direction to the drag force or in the direction of the drag force to control the drag. All the wings are made with aerodynamic design to ensure smooth operation of the payload. So moving on to the materials to be used. In order to maximize aerodynamics and reduce the drag on the wing, material selection is the most carefully considered topic in this project. The selection of the materials can affect surface smoothness, strength, flexibility, and also weight of the payload. The material that we have selected is carbon fiber. The carbon fiber can be used for the wings, ribs, and wing spare. The other material that we have selected is polypropylene. Polypropylene being the lightest one of the lightest material will be used for aerodynamic surface and winglets. So moving on to the rationale for selecting these materials. It is possible to design a lightweight payload while keeping structural integrity of the payload since carbon fiber are extraordinary in strength in relation to its weight, which means that the carbon fiber require very less weight, and compared to that it gives excellent structural integrity. As carbon fibers has limited thermal expansion, it maintains structural integrity and stability even during temperature when the temperature changes. So this is a major factor when the payload rises, the temperature may change and other materials may expand or contract, but carbon fiber has a limited thermal expansion which helps in such situations. We also use polypropylene. Since polypropylene is a lightweight, it is appropriate for low stress application such as balloon payload wings where there aren't many structural requirements. Due to its numerous chemical resistance, polypropylene may be advantageous in settings where exposure to particular compounds is a concern. So the chart here shows the property of the polypropylene, consisting of density, tensile strength, water absorption, elongation, softening point, melting point, thermal expansion, and specific volume. So moving on to the last part, that is the calculations for selecting this particular design. We use the following formula to determine the expected performance of a balloon payload with carbon fiber wings. That is, drag is equal to 0.4 into RHO into A into V raised to 2 into CD, where drag is the total drag force in newtons, RHO is the air density in kilogram per meter cube, A is the wing reference area in meter per square, V is the airspeed in meter per second, CD is the coefficient of drag. The figure on the right shows the plot that we have took from a research paper. Figure shows the effect of the actuator boundary for the case 1 and case 2 for the extended mass span-wise location.